Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be continuing our talk about polynomials by more specifically talking about operations on polynomials. We're going to talk about how to perform the operation of addition and subtraction on polynomials and practice some examples and hopefully come up with a procedure for these different operations. Now, first up, we should talk about how to perform addition on polynomials. You'll notice here that we have two polynomials. We have a 3x to the third and a 5x, and then we have the polynomial 2x cubed minus 2x. So we're adding two binomials together. And how are we going to do this? Well, intuitively, looking at this is actually pretty easy. Why don't we just try to combine our like terms? We can combine the 3x cubed and the 2x cubed together to get 5x cubed. And then we could combine the 5x and the negative 2x to give us a positive 3x. This is it. This is how you perform addition on polynomials. It's as simple as combining like terms. So what I will say here for the process, first up, make sure you distribute / simplify any polynomial / expression. What I mean by that, make sure there's if there's a distribution in the problem, make sure you do that. If there's already some like terms, try to combine them together, whatever. What I want you to do is make sure you've simplified everything down so that way you don't need any of these parentheses, okay? See, make sure if there was, for example, a 2 on the outside, use our old property of going ahead and distributing into the expression already, okay? So do that before you do anything else. Once you've simplified anything, okay? Once you've simplified everything, go ahead and combine all like terms. Combine all like terms. And remember, when we say like terms, we mean terms with the same variables or variable and the same exponent. So like terms have to have the same variables and the same exponents on those variables. So that's why the like terms here were 3x cubed and 2x cubed, because they both had the same exponent on x. Also, a 5x and a negative 2x, because they both just have that single x term. And that's pretty much it. That's really as complicated as it gets with combining polynomials. You've done this before. You just didn't realize you were working with polynomials. So again, just combine like terms. I will say, after you combine like terms, make sure to write your answer in descending order. Write whatever you get, your result, in the descending order, okay? And really that's all you have to do. It's pretty simple to go ahead and add polynomials together. Now let's talk about subtraction. Again, this is something you've done before, you just haven't realized yet. If I gave you this expression and this expression and I said to subtract them, what do you think you would do to simplify this down? Well, hopefully you're saying, well, the first thing I would do is distribute the negative. We got to get rid of the parentheses. by distributing the negative to the entire polynomial here, the entire expression. So we end up with a 3x squared plus 2x minus 5. And then we are going to subtract 4x squared. We're going to add 7x, and we're going to subtract 2. I've gone and I've distributed the negative to all of the terms. So all we did here was distribution. You've distributed everything through. We got rid of the parentheses, and now we would just combine the like terms. Well, what are the like terms? We got a 3x squared and a negative 4x squared. That's negative 1x squared. We have a positive 2x and a 7x, so that's a positive 9x. And then we have a negative 5 and a negative 2. That should be a negative 7. So we end up with negative x squared plus 9x minus 7. I got it written in descending order to make it easier for ourselves to read. And there we go, that's it. We've just performed subtraction on two polynomials. The definition for subtracting polynomials, I really like it because it highlights the simplicity of what's going on here. The definition says, let A and B be two polynomials. So imagine you just had two polynomials, okay? Any two random polynomials. Then A minus B is equal to A plus the opposite of B when I make B negative. So this just goes to show if you're going to want to do subtraction, it's the same thing as addition. You just have to distribute the negative first and then combine your like terms. So let's go ahead and write this process down. Step 1, very important. Distribute the negative. Distribute the negative. We got to get rid of parentheses. Must remove parentheses. Okay? We got to get rid of the parentheses or clear them by doing distribution. Once you do that, combine the like terms. Combine the like terms, and then really just write your answer in descending order. Write answer in descending order. And that's all there is. You have been doing addition and subtraction of polynomials. It's just combining like terms. It's just you didn't know that these expressions you were working with were in fact polynomials. But now we've just put a name to them. And this is really all that you have to do here, okay? Make sure you distribute first. This is where I always see the biggest mistakes that tend to happen. We tend to forget to distribute, okay? And if we do distribution, sometimes we forget one of the terms. Usually students will forget either the last term or the first term. So just be careful with that. Just make sure you're double checking your work and you're doing your distribution. But once you do that, it's as simple as combining like terms. Let's go ahead and take some time to practice some of these problems. I like to start by practicing some subtraction, since that's the one it's the same thing as addition, but just a few more steps. Why don't we take some time, pause the video, and work through these 3 example problems. Then let's check back in and see what you get. All right, well, hopefully you had some time to work through these problems. I like to start with the first 2 problems first and then get into the third one. You'll see in both problems I distributed the negative to all of the terms in the polynomial here. I changed the signs from positive 12 w to the 4th to negative, and from negative w squared to positive. So we've changed all the signs there. And we've also changed the signs in the second one. Instead of negative 5x cubed, it became a positive. Instead of negative 2x, it became a positive. And instead of negative 4, it became a positive as well. So again, we're being careful. We're just changing all of the terms here. And you'll see we ended up with a large expression with no parentheses needed. And then it just became a matter of combining the like terms. For 8w to the fourth and negative w, for 8w to the fourth and negative 12w to the fourth, we would end up with a negative 4w to the fourth. And then for 3w squared and 1w squared, that made 4w squared. You are allowed to have polynomials with different variables. It doesn't really matter. That's totally allowed. X was just, in our definition to represent a variable. You could have y, you could have w, that's fine. Take a look at the second problem. When we combine the like terms here, we had a negative 8x cubed and a positive 5x cubed. That made a negative 3x cubed. Be very careful when you're combining these like terms to make sure you're working with the proper signs, okay? We also had a 6x and a positive 2x to get 8x. And then we had a 7 and a 4 to make an 11. And that was it. These are our final answers. We wrote them in descending order, so we're good to go. Now let's take a look at the third problem. This is an example of a multivariable polynomial. You are allowed to have multivariable polynomials. We're only going to work with them as examples, for addition and subtraction and, theorize what we would do in this case. We're really not going to work with multivariables in this class as far as graphing goes and analysis, okay? We're always going to stick with a single variable polynomial. But if we did have a multivariable one, let's take a look at how we would solve this. Again, you would want to distribute everything through, and as you went and distributed, you'd change all of the signs on that polynomial. So we still have the negative 8x squared y squared, a positive 6x to the first y squared, and a positive 7x. But now with the negative distributed, we'd have a negative 5x y squared, a positive 2xy, and a positive 4. When you get to multivariable polynomials, this is where people tend to make the most mistakes in combining the like terms. It's helpful to kind of identify what they are, maybe to underline them or to circle them. So let's take a look here. Are there any like terms with 8x squared y squared? Well, in the rest of this expression, I don't see any term that has an x squared and a y squared. Remember, like terms have to match the variables and the exponents. So you have to have the same variables and you have to have the same exponents on those variables. Well, there's no other x squared and y squared, so there won't be a like term for this one. So we'll just leave that. Let's move on to the next one. A 6xy squared. Do you see any other term with an x to the first and a y squared? Well, I'm seeing one right here, the negative 5xy squared. So those two are like terms. And let's go to the next one, the 7xy. Do you see any other term that has a single x and a single y? Yeah, right here, it's 2xy. They have the same variables and the same exponents. And then what about 4? Well, there's no other just plain old number in here, so that won't have a like term. So let's go ahead and combine what we can, and we will end up with, well, that's a negative 8x squared y squared. That didn't combine with anything. But then we had the 6xy squared and the negative 5xy squared. That is a positive 1xy squared. We combine the coefficients to get from 6 and negative 5. That just makes a positive 1. And then we still have the xy squared as the variables. Let's see, the 7xy and the positive 2xy makes a 9xy. And then the 4, again, doesn't combine with anything. It just comes down to the rest of the expression. And there you go. This is our final answer. We've gone and we've done the distribution, and we've combined all like terms. Now, sometimes students will say, well, wait a minute, Linford, how do we write this in descending order? Because there's different variables to account for. When it's a multivariable, don't worry about it. It's fine. So I'm not going to be particular about how we write polynomials that are multivariabled. It's really the single variable terms where I want us to take that step and make sure we write our answer in descending order. So hopefully this is making sense to you. What I'd like to do now is make it a little more complicated. Take a look at this example. This is where you can think of multiple polynomials being affected by different sets of parentheses. I have the polynomial 5 and 2x plus 4. I want to subtract those, and then I'm multiplying it by the polynomial 3 so that this becomes one large polynomial, and I'm subtracting that from negative 3x and negative 4. So the question is, how on earth do we do all of this? You'll notice we have parentheses, we have brackets, we have terms on the outside, terms on the inside. How are we going to do this? Keep in mind that before we go and combine any terms, we said you have to do all of the distribution. You have to clear all the parentheses, the brackets, the braces, whatever. You need to clear all of the grouping terms, okay? All these grouping symbols. And you can only do that by distribution. So pause the video, take a minute, see how you can work that distribution to clear these grouping symbols. All right, well, hopefully you were able to spend some time working through this example and seeing the different ways we could go about distributing this. What I would say to do first is when you have an expression with parentheses and brackets, if you wanted to clear them, you have to start on the innermost set of grouping symbols first. Here we have to start with the innermost set of parentheses. I'm going to distribute that negative to get negative 2x minus 4. That has gone and gotten rid of the parentheses. I just did what the distribution required. I don't like to go ahead and distribute to the outermost, because what you're saying to do there is to distribute the 3, and you still don't get rid of the parentheses because you still have to distribute the negative through. My personal preference is to always distribute so you clear the innermost set of parentheses first. It's what I think is really the easiest to do. So we end up with the negative 3x minus 4, and then we're subtracting 3 times. We can combine some like terms in here. The 5 and the negative 4, so we have negative 2x. 5 and negative 4 makes positive 1. Okay, so we've simplified whatever was on the inside for us. Now what we have to do is see if we can get rid of the brackets. We're being asked to, again, distribute. So let's distribute the negative 3. This is, again, where a lot of times students make mistakes. They forget to carry the sign along with it. So we'll end up with a negative 3x minus 4. And then let's distribute the negative 3. Negative 3 times negative 2x is a positive 6x. Negative 3 times 1 is negative 3. And there we go, that's it. We've gone and we've cleared the set of parentheses and then the set of brackets. We started with the innermost and then we worked our way outwards. So now we can go ahead and combine the like terms. Well, I'm seeing a negative 3x and a positive 6x, so that should be a positive 3x. And a negative 4 and a negative 3 makes for a negative 7. And that's it. That's our final answer. It's written in descending order, and we've combined all like terms. Hopefully this is making sense to you and you're getting the hang of this process for addition and subtraction. But if you do have any questions or comments, feel free to let me know. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions or comments. And until next time, take care.